Hello everyone. In this lecture, I will going to start a new chapter, molecular spectroscopy. Okay. First is the content of this chapter. Now, in this chapter, we have to study first one, introduction of this chapter. What is meant by molecular spectroscopy and so on. Then we have to study the different energy level. First one is the rotational energy level. Rotational energy level. Next one is the vibrational rotation spectra. Vibrational energy level. Vibrational energy level. Next is the vibration rotation spectra. Vibration rotation spectra. Then electronic spectra of molecule. Electronic spectra of molecule. In which electronic spectra of molecule we have to study two concepts. First one is the fluorescence, and next one is the phosphorus. Yes, I have to yes, phosphorescence. Check this spelling, phosphorescence. Okay. Now, in this lecture, we have to discuss what is meant by molecular spectroscopy. Okay, the introduction of this introductory part of this molecular spectroscopy. Okay, what is meant by spectroscopy and so on. Now, the molecular spectroscopy is the study of, I have to write here first definition, then we have to discuss what is meant by molecular spectroscopy. Molecular spectroscopy is the study of the molecular spectroscopy is the study of the interaction of electromagnetic waves and matter. Okay. Now, in a molecular spectroscopy, we have to study the molecular spectroscopy is the study of interaction of electromagnetic waves and matter. Okay, you have to know these two concepts. First one is the electromagnetic waves. Okay, what is meant by the electromagnetic waves? Electromagnetic waves, how was this electromagnetic waves is propagated? When electric and magnetic field are perpendicular to each other. Okay, electric field and magnetic field are perpendicular to each other and then gives rise to the electromagnetic waves. Okay, suppose electric field in this direction and magnetic field in this direction. Okay, electric field in this direction and magnetic field in this direction, and electromagnetic wave is propagated when these two fields are perpendicular to each other. Okay, like this, when these two fields are perpendicular to each other. Okay, and then the wave is propagated in third direction like this. Okay, electric field, the direction of electric field is like this, and the direction of magnetic field is like this. Okay, electric field and magnetic field like this. This is the direction of electric field and this one is the direction of magnetic field. This gives rise to the electromagnetic waves. Okay, now I have to discuss then matter. Okay, matter means what? Matter is the combination of atoms, ions or molecule. Matter is the combination of atoms, ions and molecule. Okay, now this interaction of electromagnetic waves with matter, that gives rise to the molecular spectroscopy. Okay, I have to again explain here. The molecular spectroscopy is the study of interaction of electromagnetic waves and matter. Okay, and how was this electromagnetic wave is propagated? Electromagnetic waves is propagated when electric field and magnetic field are perpendicular to each other. Now the matter is what? Matter is the combination of atoms, ions and molecules. Okay, now this interaction of electromagnetic waves and matter, that gives rise to the molecular spectroscopy. Now in which molecular spectroscopy, molecular spectra classified these molecular spectra by increasing order of energy. Classification of molecular spectroscopy by classification of molecular spectroscopy. Okay, by increasing order of energy. Increasing order of energy. Now the classification of molecular spectroscopy. In which molecular spectroscopy? The first one is the, according to increasing order of energy, first is the radio waves, then microwave, then third one is the IR, next one is the visible, then UV, then X-ray and gamma ray. Okay, radio waves having lowest energy molecular spectra, then microwave, IR, visible, UV, X-ray and gamma ray. Okay, gamma ray are the very high energy. Now I have to discuss here one by one. First one is the gamma ray. Okay, gamma ray, we have to know the alpha particle or beta particle. Okay, alpha or beta are a particle, alpha and beta are a particle, but gamma is the source of radiation. Gamma are not a particle, it is a source of energy radiation. It is a source of radiation of energy radiation. And how was this gamma ray as produced? Gamma rays are produced when an atom or molecule are in excited state. Okay, excited state. This star indicates that the atoms is in excited state. When this de-excitation of an atom to the ground level by emitting some photon, and this ray called as the gamma ray. AXZ. Okay, that is called as the gamma ray. The frequency of this gamma ray, is 3 into 10 raised to 8 to 3 into 10 raised to 20 hertz, and wavelength is 100 picometer to 1 picometer. Okay, you have to know this relation. E is equal to h nu and nu is equal to c upon lambda. Okay, therefore this relation hc upon lambda, E is equal to hc upon lambda, means energy is directly proportional to frequency. Okay, energy increases, frequency also increases and wavelength decreases. Okay, therefore the gamma ray having Very high frequency means very high energetic particle, and the wavelength is too small, okay, because of this formula. Then next one is the X-ray. Second one is the X-ray. Okay, X-ray, you have to know that X-ray are a very high energetic electron, very high energetic electron, and we have to know, you have to know everyone whatever the use of X-ray. Okay, then the frequency of this X-ray is 3 into 10 raised to 16 to 3 into 10 raised to 18 hertz, and wavelength is 10 nanometer to 100 picometer. Okay, then next, third one is the UV visible. UV visible. The UV visible, you have to know the hydrogen spectra, in which hydrogen spectra the Balmer series are lies in UV visible region. Okay, this UV visible region is possible when the transition of an valence electron, due to valence electron transition gives rise to the UV visible spectroscopy. Then the frequency of this UV visible spectroscopy is 3 into 10 raised to 14 to 3 into 10 raised to 16 hertz, and wavelength is 1 micrometer to 10 nanometer. Okay, 1 micrometer to 10 nanometer. Then next one is the IR spectroscopy. Next one is the fourth one, IR spectroscopy. In IR spectroscopy, it is related with the vibrational spectra of an molecule. Vibrational spectra of an molecule. Okay, due to vibrations of an atom or a molecule gives to the IR spectroscopy. Okay, now the frequency of this IR region, that will be 3 into 10 raised to 12 hertz to 3 into 10 raised to 14 hertz, and wavelength is 100 micrometer to 1 micrometer. Okay, the next spectroscopy is the microwave region. Next is the microwave region. The microwave region, in which the transition in an rotational spectra. Transition in an rotational spectra. Okay, रोटेशनल स्पेक्ट्रामध्ये जे काही ट्रान्झिशन होतं तर ते कशामध्ये होतं, कुठल्या रिजनमध्ये होतं तर मायक्रोवेव्ह रिजनमध्ये. ओके, अँड द फ्रिक्वेन्सी ऑफ दिस मायक्रोवेव्ह रिजन इज 3 into 10 raised to 10 hertz to 3 into 10 raised to 12 hertz, and wavelength is 1 centimeter to 100 micrometer. And then last one is the radio frequency region. Check this spelling, radio frequency region. The radio frequency region in which there is a nuclear spin transition. Okay, nuclear spin transition, you have to know this concept, nuclear spin transition. Okay, in an NMR, for example, the nuclear spin, in an NMR there is a transition is due to the nuclear spin. Okay, and the frequency of this nuclear radio frequency region, that will be 3 into 10 raised to 6 to 3 into 10 raised to 10 hertz, and wavelength is 10 meter to 1 centimeter. Okay, this is all about the molecular spectroscopy. Now we have to discuss types of molecular spectra. Okay, types of molecular spectra, that will be discussed in a next lecture. Okay, thank you.